Hello, I saw your next question here. Graph two periods of the given tangent function. So y equals negative tangent of 1/3 x. And so I guess if I shrink this down, we need to look in your book. This is section 2-3, page 98 here. And I guess this box here, we'll make it larger just for a moment. This box here, graphing y equals a tan quantity bx minus c. So it talks about, here how to find two consecutive periods where your asymptotes will be located at. It's these things here. This is its general shape. And so that, keeping this box in mind, you just need, this course has a lot of memorization. You just need to memorize this box. So we set what's in the parentheses equal to negative pi halves and positive pi halves, and that'll give us these two consecutive asymptotes. So if I do that, I'll just write up here 1/3 x will equal pi halves or negative pi halves. So set what's in the parentheses equal to pi halves and set what's in the parentheses negative pi halves. Here you would just multiply each side by 3. And so we just get x equals 3 pi halves. And if we put negative pi halves here, you put negative pi halves here, it'd be negative 3 pi halves. So that tells you the two asymptotes are 3 pi halves and pi halves. So we know where the asymptotes are. The x-intercept occurs halfway between them. Now, normally the thing's increasing. Okay. But your particular example has a minus here in front. If you remember from college algebra, the minus will reflect it about the x-axis here. Instead of going like this, it's going to be going just the opposite direction. And so, and the 2 will stretch it a bit. And so, this is it. It's reflected across the axis, and got the asymptotes in the correct place. This one's not reflected, you see. It has the right asymptotes, but it's not accounting for the negative. Let's see, it seemed like there was another question you had. Let's look at that. So here, you want to find the exact value if possible. So from the previous problem, we have to look from negative pi halves to pi halves, which we have that. The inverse sine and the sine are opposites, so they're just going to cancel, leaving you with pi sevenths. Okay, so these two are opposites, just leave you up to pi sevenths. That's within the negative pi halves to pi halves range that was mentioned in the last video that I just sent you. I hope that helps.